Science, 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 science.
Welcome to the second edition of A Moment of Science with Mr. Solis. Today we have again Mr. Quintero from down the hall and a special guest, Mr. Benavides from what school? You know what? Why don't you go ahead and introduce yourself, Mr. Benavides?
Sure. Hi, I'm Mr. Benavides, and I teach sixth grade science at Harlandale Middle School. And should I say anything about myself?
Yeah, go ahead.
Science, and I love dogs, and my favorite food is cheese.
Really? Like just cheese by itself, or enchiladas, or anything like that?
Really, if anything has cheese on it, I'm probably gonna, you know. Yeah, that's why I just say cheese. Like, it's my favorite. I guess you could say it's my favorite ingredient.
I saw a meme a couple of weeks ago when all this quarantine and coronavirus stuff was getting started, and it said, you know how the people were buying all the toilet paper. One person said like he bought like 5 pounds worth of cheese, and he said, "Now I won't need any toilet paper."
That's a person who thinks ahead.
That's clever. Okay, so before we get started, how are you guys coping with the quarantine? What are you guys doing to keep yourself sane? Because I can already feel I'm getting antsy. So what are you guys doing?
Well, I get online and I find like on YouTube or on Facebook, there's like free workouts you can do in your living room right in front of the TV. And so I have like a thing where I can put like the internet right on my TV. So I've been trying to do these workouts, and that makes me feel a little better with all that like antsy energy I have.
Yeah. I'm eating outside now. I put the table outside, and we're just eating dinner outside now because I think I was just stuck inside, and you need to have that sun. You need to like feel the wind. I'm outside right now, and I'm like, I just have to be outside because being inside around walls, I start to feel like I'm in prison. So that's my new remedy, just going outside and feeling the wind and seeing trees and stuff.
Ooh, I'm going to start doing that.
Yeah, I was outside for a little while yesterday with my daughter. I was like, man, we were practicing softball, which gives me a little bit of an out because I'm like, I feel like, I actually feel like I'm gaining weight again. So I'm like, man, I gotta really start. I gotta start working out because you feel trapped inside your house all day, and you're like, man, it's starting to get to me. So I've been coming outside, and today's a good day to come outside because it's supposed to rain the rest of the week. Apparently, it's going to be raining, so it's a good idea. Wow. Yeah, it's a good idea to get outside right now. But it's been a challenge. At first, it was like and then now it's like, it's frustrating, very frustrating.
Yeah.
But I tell you what, this first week I was learning a lot from Google Classroom. I'm still learning, trying to figure it out to try to get engagement for my students. So I think along with the students learning how to use it, I'm learning how to use it as well. So it's kind of like a process. By the end of this, we'll probably all be experts.
I think my students are mad at me because for like 2 of the different like assignments, I posted them up wrong. So they couldn't actually do it. What happened was they did it, but I'm pretty sure it was the way I did it wrong. So like I couldn't see their answers. So I was like, sorry guys, you got to do it again. And they're like, oh, Mr. Benavides. I'm like, sorry.
Yeah, I had that same issue. I had to learn how to return an assignment so they can resubmit it. I figured that out because I tried returning one, but I graded it and I locked it, and I was like, oops. So there's a way to do it without locking it, and I had to figure that out. So this is Edward still with us?
I don't know, Mr. So, are you there?
Looks like his screen locked up.
Yeah, he's the director of this movie. What are we gonna do with that guy from the theater? Oh no. Well,
can you see it? Can you see his face on your computer, on your phone?
I see like it looks like his camera's turned off. I see like the letter E for Edward Solis. Oh, now it says he left the call. Maybe he's gonna join. So kids who are watching this, as you can see, just because we're the teachers, we don't have all the answers, and we're figuring stuff out as we go too. Oh, and now I see your camera's off, Mr. Quintero. Can you see me?
I can see you. Yes.
Okay, I just see a
I can.
purple.
I can see you and I can hear you.
Okay, okay, cool.
So we're seeing what may have to happen is he may have to
Start it.
Yeah, because he was the main guy doing it, so he may have to start it over and then join in again. So this is the kind of stuff we're learning how to do.
Yeah, this is, and I think it's okay for them to see that. It's almost good that they see this so that they don't think that, you know, just because you're a grown up or just because you're the teacher, you automatically know how to do everything or have all the answers.
Yeah, we're learning is lifelong. I think that's what students need to know.
Yep. And you might as well be open to it, you know.
Yeah. Yeah, for sure.
Come back? Oh no.
No, I'm gonna text him right now to see
cool.
if he's trying to get back on.
Oh, okay. In the meantime,
let me call him. Let me see.
Let's think of some fun science facts to tell these guys. In the meantime, did you know that an African elephant is pregnant for 2 years?
Wow.
I learned that on the Discovery Channel. Back when
that's insane.
Mm-hmm. I'm glad that I'm not a female African elephant because I have no interest in being pregnant for 2 years.
Wait, what happened? I just came back and I heard I'm not interested in being pregnant for 2 years.
Well, what happened was we saw that you got like kicked off or something.
Yeah.
Recording. So we were just talking. We were kind of improvising about like, oh, this is good that this happened because, you know, for the kids to see that we don't always, you know, we're learning too, and that we don't always have the answers just because we're grown-ups or because we're teachers. So we're learning along with them. But then for fun, I thought I would tell the kiddos a random science fact. And the random science fact was that African elephants are pregnant for 2 years.
Oh, shoot.
Yeah. So a human takes 9 months, but an African elephant takes 2 years. I guess because it's just such a bigger baby.
Yeah. Wow, that's crazy. I didn't know that. Mm-hmm. Hey, Quintero, is he frozen on your screen?
No.
Really? He's frozen on my screen.
No, not you were frozen on mine.
Right now?
No, before you got off, you were frozen, and we were talking, but we couldn't hear you, and then so we figured out that something must have happened, and that we thought we were gonna have to start all over. Was it still recording?
No, it wasn't. But I'll put a little disclaimer saying we had technical issues.
On the top of mine, it still said recording on my screen.
Oh, then yeah, you know what? It probably is
the whole time.
Yeah.
And it still says it hasn't stopped. So, but
Oh, well, that's good.
It's actually captured.
Yeah, I'll see it in a little bit. See what we got.
Yeah.
All right, so we talked about what we were doing to not drive ourselves crazy. Now let's talk about space for a little bit. Sure. I got some questions. My first assignment for space was I showed them like a video of the Earth, and it's like zooms out from a girl's eye, and it goes all the way out to like the edges of the universe. I think it's on YouTube. It's pretty cool. And then I asked the students, okay, just give me a question. What do you think about what does this make you think about? So here's some of the questions, and then we'll try to answer some of them. Some of them are really deep. Like I'm like, oh wow, I can't believe you're thinking about stuff like that. Others are just normal questions, I guess. Can space get any bigger? What do you think?
What the question was? Can space get any bigger?
Yes. Like right now, I guess they think maybe it's a finite size. Can it get bigger? Is it getting bigger? What do you think?
Well, when I was in my early 30s, I used to work at a place in Chicago called the Adler Planetarium.
Mm-hmm.
And it's a cool place because it's the oldest planetarium in the country. And, you know, I was just like in the education department working with little kids. So I was doing little activities like, you know, easy science stuff.
Yeah.
I became real good buddies with this guy who worked at the planetarium, and he was a PhD, which is like a type of doctor, not a medical doctor that like operates on people, but like it means he's an expert. And he was called a cosmologist. And a cosmologist is sort of like an astronomer. They know all about outer space. And he was so smart. And like I would every day we would have lunch together in the cafeteria, and we would eat chili. I don't know why that was our ritual, but I would put cheese on my chili. And I would ask him about space and stuff. And he tried to explain to me one time how, like, there's a theory that space is expanding, like not like stuff in space getting bigger, but like space itself. They think that the universe is like actually getting bigger. And I thought, I don't know much deeper than that, but I think that there's some smarty people who think that it is getting.
What do you think, Quintero?
I think that we know it's expanding, so we know that for sure, and it's expanding exponentially, like it keeps expanding faster and faster, which is fascinating. But like you said, we don't know, is there an outer boundary to the universe? Like, are there multiverses? And there's also a theory about multiverses, so that's interesting. But some of the things that we don't have answers to, but we keep searching for those answers, and that's what makes science interesting. But I think that honestly, we know it's expanding, but is it getting bigger? I mean, it may be finite, it may be, or maybe infinite. We don't know. I mean, that's the thing that makes science so interesting, is that we keep discovering. It's this the discovery of all these new things. But yeah, very interesting. That's a good question.
Now, yeah, whenever I start the teaks with the students every year, I've always tell them, like, this is the one teaks where most of the time you're going to ask me questions and my answers are usually going to be, I don't know. And it's not because I don't care.
Uh-oh. You froze, Edward. Is he still talking on your end, B?
Mr. Solis, no, it's like he got cut off on my end.
Yeah, mine too. Again, let me see. Let me text him back again.
Here, try texting again.
Yeah. You got cut off again. I'm gonna take a picture of his face on my screen. I'm gonna send it to him. I said, "You frozen on my screen again." Yeah, I love space. Is one of my favorite topics because there's so much to learn, and there's so much to be discovered. I love watching those videos on space because they're just so interesting.
Yeah. One thing I show to my kid, well, I always show it twice in the year. There's this website, and I'll email it to you guys so you can have it and share it with your kids, because I can't remember the exact. I mean, I always have to kind of Google it to remember. It's called, I think it's scaleoftheuniverse.net. Do you know that one? Or
oh, is that? I think I'm gonna have to look it up because I've seen several of those.
It's the one where you zoom in to like smaller than like a quark, and it zooms out to like, you know, the size of the known universe. And it's so neat.
Is it a like an animation one? Like yes. Is it like a cartoon like type one that you can actually control zoom in and out?
Let me see. I'm on my phone here. Let me see if I get lucky and my computer decides to start cooperating with me, and I'll try to go to it right now. And I don't know if I can turn around my camera. Let's see if there's like a way to turn around the camera. No, I don't think you can on here, but it's okay. I'll turn the phone around. Let me just see. Scaleofuniverse.com. Is that it? Click to use Flash. Okay, I guess I'll use once. I don't know. Scaleofuniverse. Yes. Oh wait, it's loading. Can you see my computer screen? Does it look clear?
It's a little pixelated, but I can see it.
Oh, okay. Well, so here, you know, you have like the size of a human, and like just a beach ball, and like everyday things, and you can zoom out to like bigger and bigger things, all the way to like planets and galaxy. Well, this is stars. It's not even galaxies yet.
I'm back.
nebula.
I see that. Yeah,
And then you
that's
can go
cool.
smaller. And then at the beginning of the school year, you know how we have to start with like history and like what's an atom and stuff. So and what's an element stuff. So you can go smaller to like it's like a hummingbird, and here's an ant, and you can go like smaller and smaller and smaller to like here's a virus. This is kind of like what a coronavirus looks like. This is hepatitis B virus. Here's a little HIV virus. Here's an ultraviolet wavelength. And it goes smaller and smaller. And then, like, this is like molecules. So it's a really cool website. So, especially now, kids, it's scaleofuniverse, all one word, .com. And, that's one that I show to my kids a bunch of times. And, it's definitely something to look at now that you got time on your hands.
Mhm.
So and I'm back again. I don't know what's going on. I think it's probably because I'm outside.
You're not close to the thing.
Yeah, I left the door open, and I hope that works. But another question that we got, speaking of the scale of the universe, is why do we use light years for measurement? So who wants to take that one?
Light years.
Like, why don't we just use feet?
Because the universe is so. I think it's hard for us to comprehend, to grasp how big space really is, because we're used to our perspective. Like, students are used to looking at from here to the end of the hall, and so to really understand the vastness of space, you have to try to understand how light moves. Yeah. So I think light years is used because that's how big space is. That's the only way you can't measure it in feet or meters, because the numbers would be too long, and you'd have to use exponentials, exponential notation to do that, which they do use scientific notation. But so you have to measure in light. Remember, to get an idea of light speed, it takes about 8 minutes for the light to reach Earth from the sun. So imagine that. You turn on a light switch. Let's say if you wanted to turn the sun on, it's dark, there's no light, and you click a light switch and you count 8 minutes on your watch, and then by that time, then the sun will actually turn on. It'll take 8 minutes. So I think it's hard for them to comprehend that. What do you mean? Like, it takes light that long to travel. That's how far the sun is from Earth. So it's still a hard concept to grasp, even for teenagers, and it's a hard concept.
Yeah. So if it takes,
I think I explain it like, imagine you're trying to measure how tall your friend is, right? And you want to know how tall your friend is. You're probably going to use feet and inches, because you don't need to use too many feet or inches or too few feet or inches to measure how tall a person is. But what if you wanted to use millimeters to measure how tall you were? That would be really inconvenient, right? Like, I'm 5 feet 9 inches. But if I wanted to use millimeters, I don't know. It's like, oh yeah, I'm making up a number here, but it's like, oh yeah, I'm 10,048 millimeters. It's like, oh, okay, that makes a point, right? Or let's say I wanted to use miles to measure how tall I am. Oh, I'm 0.0005 miles tall. No, so with light years, space is so enormous. That's just like the size of the unit you want to use, because the distances are so gigantic. It's just crazy.
Yeah.
So one of the coolest things that I heard is that since light takes so long to get to Earth, that basically every time you look up at the night sky, you're looking at the past.
Mm-hmm.
Yeah.
And that's pretty.
I love that. That's so philosophical.
Yeah, especially, or even at the sun. Every time you look at the sun, you're looking at the way it looked 8 minutes ago.
Mm-hmm.
Yes.
So the stars you see every night might not even be there anymore.
Yeah, it could be gone already. You're right. Well, that's what they say, that you could be looking at light that has been traveling to Earth since the dinosaurs, right? That's crazy.
Mm-hmm.
That's hard to understand. Like what? It just blows your mind. Like wow.
Yeah. So like the light that we get from the stars, it's kind of like an email because you get a picture and people can attach a picture to an email, right? You can attach what a JPEG or a GIF or something. But really, we're not able to open that email until, millions of years after it was sent. So light is not actually the fastest thing. Well, it's the fastest thing, but it's not as wish it was.
Yeah,
You know what?
Yeah.
I like that.
We have no way of knowing what things really, 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 really far away look like today. We only can open the email that was sent millions of years ago.
Yeah,
Yeah.
I like that. I never thought about that. All right, let's go to another student question. This is a pretty philosophical one. How will it all end?
Well, that's a crazy question, considering what we're going through right now. Because I don't know. I mean, it could be anything. I mean, we have all kinds of variables on this planet. Remember, we also have the human factor on this Earth. But how will it all end as far as space is concerned? Well, the sun expands into a red giant. I mean, maybe 5 billion years from now. So that's how it's supposed to, as far as the solar system is concerned. But I mean, we can talk philosophically about this one because there are other factors that can determine how this is all going to end. Coronavirus. No.
Yeah. Well, I saw a really neat. It was actually when I was working at the planetarium. They had like all sorts of cool videos you could watch and stuff. So I was watching one, and they were talking about how the universe is believed to be expanding, right?
Mm-hmm.
And eventually, everything is going to become so far away from each other, and the speed at which stuff is moving away from each other is increasing, right? And eventually it's going to outpace the speed of light, so that like eventually we won't even be able to see the stars in the sky, kind of a thing, because the light is slower. So what they think, and this is like really crazy, like theoretical, like far out there, we can't know with certainty, but it's still a really cool theory, is that eventually there's going to be so much expansion of space, and it's interesting. It's kind of like things aren't moving away from each other; they're staying still, but the space itself is getting bigger. Isn't that weird?
Yeah,
So
yeah.
they use the example of like take a rubber band, okay, and draw 2 dots on the rubber band, and then just stretch the rubber band. Those dots are still on the same point on the rubber band, but the rubber band itself is getting stretchier. So that's kind of like what's happening with space, right? So eventually, what they think, there's going to be this thing, it sounds horrible, it's called the heat death of the universe, where the universe is going to just become this dark, cold place. But the hopeful thing, which I thought was super cool, is that, in this same like documentary I saw, maybe future humans who are so advanced and have learned so much science and they've gotten so smart, we might even be able to figure out a way to like travel to a different dimension or like another universe in the multiverse, like Mr. Quintero mentioned, and continue to live and exist and play Fortnite.
Okay, so this is really gonna blow your mind because I like that you brought that up. The heat death of the universe. So I read, no, I didn't read it. I heard it from a podcast, the Joe Rogan podcast, saying that it's possible. Well, it's not possible, but they kind of went off on a crazy tangent. And they said, "What if we are already like a second away from the heat death of the universe, but we're so advanced that we cannot stop the heat death, but all we can do is expand the last second of time to an infinite amount. So that's what we're living right now. Like, we found a way to stretch time open so the universe is going to end in 1 second, but we don't want to die. So all we're doing is that last second, we stretch it out like a rubber band. And now we're just living that 1 second, and we're stretching it as long as we can so we can try to figure out the answer to how to stop it, because all we can do is mess with time, but we can't solve the mystery of how to stop ourselves from dying in the universe. And when I was listening to that, I was driving, I was like, oh my God, this is the craziest thing I've ever heard.
That is the coolest idea. That is so neat.
Yeah.
Like, it's like the heat depth of the universe wants to get it, but we're it's like chasing a carrot on a stick.
Yeah, exactly.
Mhm.
Keep stretching out that little last bit of time. That's a really cool idea.
So this is what I really like about this teaks, is that this teaks really allows you to expand your mind more than any other teaks, because there's really no wrong answer as long as you're using some type of scientific backbone to your theories of what you think is going to happen in the future, because nobody really knows what's going to happen. I mean, in an infinite universe, basically anything is possible.
Mm-hmm.
Yeah.
Yeah.
Yeah, I think that
And that's
one thing I think about is that I know that in 45 years, hopefully around, I live at least that much longer, but that I am one thing I am sad about is that I'm not gonna live in the time where we will have space travel. You know it's gonna happen.
Me too.
You know it's gonna happen, right? It's gonna happen. We're gonna get there one day. 1,000 years from now, 5,000. I mean, we're pushing boundaries, and I'm not gonna. It's kind of the sad thing that I think is that I'm not gonna be alive to live in those moments.
Like space travel, like Futurama or Rick and Morty or stuff like that, where you can just go to
like going
Mars,
like a Mars colony. I mean, even that, just a Mars colony would be cool.
Yeah.
And we're laying the seeds for that now, but so that's where we're at. We're in the moment of laying the seeds for that, and all these future generations will be able to live those moments.
So if we were going to compare it to history, we're like at the moment where we're barely learning how to build boats.
Yes, for space. Yeah.
Mm-hmm. Yeah.
But I mean,
I
go ahead.
guess one, and it's not like to. Oh, sorry. I was just gonna say it's not like to discount Mr. Quintero's feelings of like, because I agree, like I would love, but I guess the point is like, someone 500 years ago could think, oh man, I wish we could live in the time when we had antibiotics.
Yeah.
Like, I guess and this isn't really a scientific point, it's more of a philosophical point, but I guess we can still lay so many positive seeds for those future generations that will get to do that stuff. And just by trying to live in the moment and try to make a positive difference here and now, but yeah, I definitely wish that I could go in outer space, because I love like science fiction, I love like Star Wars, Star Trek. Well, look, you see, like, so yeah, I totally agree, but I don't know, like when I was little, I used to wish that I lived in like ancient times, because I used to be obsessed with Greek mythology.
Yeah.
Oh, yeah.
And so I don't know, like it's kind of the same thing, like like just try and be in the moment and study science.
So bringing it back to the teaks, why are we trying to get to Mars, and why is it not possible right now for us to live on, let's say, Saturn? What's the difference between those two planets? Like as far as the terrestrial land, as far as their physical properties, why is it possible for us to set up colonies on Mars, and why is it not really probable for us to go to like the 4 outer planets?
Well, I guess Mars is rocky.
There you go.
And Saturn is a gas giant.
Yeah.
So you can't actually walk on Saturn. You would just be like, I don't know, floating on a giant marshmallow of Saturn.
So the first four planets, the first four inner planets are rocky, the terrestrial, and the four outer planets are known as
The
the
gas.
gas giants, right? And another little factoid that students, most students don't realize until after we tell them is that Mercury or Venus is actually hotter than Mercury. Does anybody want to explain why that is?
That's a good question. I don't know why.
Well, because of basically. Oh, go ahead, Frank.
Well, this is what I think. But have you guys ever heard of the greenhouse effect?
Yeah, that's exactly right.
Mhm.
Yeah, so we have a lot of pollution from like cars and burning coal on Earth. So what that does is it gets into it puts these gases, these chemical compounds. Well, everything is a chemical, right? But it puts these chemical compounds into our atmosphere, and it makes it so that heat can't really escape the Earth so easily. So it kind of traps the heat in like a warm, snuggly blanket. And so, on Venus, they have those guys over there on Venus. Venus has super. I think it's is it carbon dioxide? What's in the atmosphere?
Yeah, I think it's CO2.
Yeah. So Venus has a lot of carbon dioxide or CO2, which is the stuff that you breathe out. You breathe in oxygen, and you breathe out carbon dioxide, and it's like dry ice, But that stuff it makes it so that the heat cannot escape the actual surface of the planet. So it's like a gigantic oven. So that's why it's actually hotter than Mercury, even though it's a lot farther away from the sun.
So Mercury is extremely hot, but like you just said, the reason that Venus is hotter is because it basically has a blanket, and that thick blanket keeps the heat in and it doesn't allow it to come out, so it makes it hotter. Why do we say, when we're looking for other planets, why do we look for oxygen? So when we're looking for like aliens or other life, why do we always look for oxygen? Why don't we look for...
We look for oxygen and we look for water. Oxygen and water. Oxygen supports life. We do know that for sure. But we also know that life, where we find life, we find water as well. Water exists where life exists where water is at. So that's another thing that we search for. But if we find oxygen, we know that there's a good chance that it could support life. But also, it could be somewhere where our future generations may travel to and find a place to inhabit. I mean, that's what the survival of the species, So planets with oxygen are good places to relocate if we ever need to.
All right. So even though we're going to talk about space travel a lot more next week, let's touch upon that a little bit right now. If we were, or I'll just make it personalized. If they give you an opportunity to ask, let's just say, 2 questions to superior life forms, what would you ask them? What would you want to know?
Ooh, I've never thought of that one. So if I could ask 2 questions to superior, like alien life forms or robot or artificial intelligence life forms.
Yeah, let's just say like aliens came to Earth and they're like, look, we're not going to fight you. You guys are like ants to us. There's no reason for us. We just want to say hi and we want to answer your questions and then we're going to leave. What questions do you have? And they say, Mr. Benavides, you got 2 questions. What do you want to know?
Well, one, I would ask, what advice can you give our civilization so that we can grow and develop in a healthy, positive way that'll allow us to continue to, advance our technology and advance our society without, basically destroying the environment and destroying ourselves. That's definitely, I would ask. So it'd be more like advice.
Yeah.
Obviously, they made it, and you should always look up to folks who are farther along than you in whatever area, right?
Yeah.
So that would be one, and I have to think about the other one.
What about you, Quintero? What do you think?
I think it has to be in the line of something that can save the planet, like renewable energy, like nuclear. How can we harness nuclear fission? How can we harness that where we can use energy without destroying the Earth, and that way the Earth would we would survive. The planet would survive because we're destroying this planet so fast. I mean, it's scary. It's a scary thought to, if you really understand, what's going on with the rainforests and all that. But that would be the main question for me is, yeah, sustainable energy, renewable energy. How can we figure that? Like, what can you give us, or what to help us along that line in saving the planet? I mean, other than that, I mean, maybe some type of medicine, like a cure. What kind of medicine advancements do they have? So I think those would be the two things, right? Like saving the planet, and then medical advancement.
Have you guys ever heard of the Kardashev? I think it's called the Kardashev scale. Have you ever heard of that, guys?
No, what is that?
It's super. So back in like the 1970s, I think he was from Russia. Well, the name Kardashev sounds Russian to me. There was some scientist. He was like a cosmologist, like we were talking about, like, or an astronomer or a physicist or some kind of scientist. He came up with this scale that so like a scale measures things, right? So this scale measures how advanced a civilization is. So the original Kardashev scale has 3 numbers on it. Number 1 is a civilization that has managed to achieve full use of their home planet's resources in a sustainable way. Okay? A level 2 civilization is a civilization that has managed to like achieve full use of their home solar system's resources in a sustainable way. That would be like thousands of years, right? And a level 3 civilization, I'm talking like Star Wars, like a civilization that has branched out like beyond the stars, right? And so, right? And the scary thing, like Mr. Quintero was just saying, we're destroying the planet right now. But according to this scale, according to the guy who came up with the scale, the most dangerous time for a civilization is when they go from like 0.99 to achieving level 1. Because that's when they're most in danger of like accidentally destroying themselves. So right now, human civilization is like at 0.99. So all the choices we make right now as a people, and I'm not even just talking like in one country, like just as like all of humanity, all the choices we make right now in the next 50 to 200 years or so, maybe, approximately, are going to determine whether we make it to level 1. But the good news is, if we make it to level 1, according to the Kardashev, according to Mr. Kardashev or Dr. Kardashev or whatever, then we're home free. Because once you've managed to safely make it to level 1 and beyond, you're pretty much safe. You're going to be smart enough and advanced enough to just, continue the survival of your civilization. So that's exciting at the same time, even though it's a little bit scary right now.
See, I did hear about that scale. I didn't know that's what it was called. And that kind of leads into the Fermi paradox. Y'all heard about the Fermi paradox?
Mm-hmm.
I've heard of it, but can you remind me what it is? Because I don't remember.
It basically says, if, like, just in the Milky Way galaxy alone, if there's like 250 billion stars, that means that there has to be, even if it's like 0.1% of other civilized or intelligent life out there, that would still mean that there would still be millions and millions of life forms out there that would be intelligent. So why don't we see them right now? If there's so much intelligent life out there, we should look up at the sky, and it should look like Star Wars. So how come we don't? It's a paradox. There's so many opportunities for intelligent life out there, but we see nothing. So why don't we see any aliens out there? And I forgot his name, but his last name was Fermi. He basically said there's some answers to this question. One of them being maybe we're the only life form. Maybe there is no such other life form out in the universe. It's just us. Or maybe life, it never reaches one. They're always at 0.999, and then they destroy themselves before they can get to one, and that's known like as the plateau. And that's kind of scary because you just said we're like at 0.99, and I do agree we're there. So that either means that we're going to advance and make it to one, and then we're going to take over our solar system, and then we're going to take over the universe, and we're going to be able to do interstellar travel, or we're going to get stuck with earthly politicians and nuclear war. And
that goes back to the human variable. Like that's always going to be.
And he says that it's possible it happens to every every civilization. The primitive forms, and they learn communication, and they learn technology, but right before they can get to the place where they can spread out into the universe, they always destroy themselves because of their own insecurities or stuff like that.
Foolishness.
Yeah.
Well, I guess, my answer to like the anxiety that produces in me, because it does, I hear that stuff, and I think it's okay to admit that, it is scary, and it can give you a little bit of anxiety, but I guess I just want to remind us, or just point out that, hey, we're still here. We still have a chance. Let's just take a moment to just sit and, and I really think that science is the answer, guys, because science, like scientific facts are true whether you like them or not, whether they make you feel good or bad, right? And I think if we can just relax and, just accept the fact that, science is a process that helps you problems. It's not just a set of answers. I think of science as being like a Swiss Army knife, because it can do so many different things, and you can use it in so many different ways. And you know what? We still have a chance, because the thing is, with the Fermi paradox and the Kardashev scale, they have this thing called the bottleneck principle, I think is what they called it.
Mm-hmm.
So imagine you're driving down a highway in your car, and your car with you in it represents human civilization. But every other car on the highway represents another possible, alien civilization out there somewhere in the galaxy, right? Then, you're on a 4-lane highway, right? And all of a sudden, 3 of the lanes get blocked off because of a traffic accident or something. So there's only 1 lane now. So now there's a traffic jam because everybody's trying to merge into the 1 lane to get past it, right? So, not everyone makes it past that accident in the road, I guess. So, but the point is, if we play our cards right, if we're smart, if we cooperate, we could still make it past the box.
All right, so we're heading in about an hour now, so I think we're going to end it here. Before we do, what is one thing you want to tell your students?
Mr. B?
I guess the first thing I want to say is I miss you guys, and I can't wait to see you. I think that, I think that we always had so much fun in class, so I can't wait to see you guys again. And in the meantime, don't be too scared of what's going on. The good, coronavirus and all this stuff and climate change and all this stuff is scary, but we have a wonderful tool in our toolkit, which is science.
Nice. Quintero, what do you want to say?
I'd like to just kind of reiterate that I miss my students. I miss them as well. I miss all the fun things that we did in class, which makes it difficult for science because we always want to do things in class with our kids, with models and stuff, and so that makes it hard for us to do online because we're so used to that interaction with our students. But I do miss them a lot, and I can't wait to get back into the classroom. I really want to be back in there doing science. So I miss you guys, and don't worry, and stay safe and stay at home.
Yeah, I want to just
wash your hands, guys.
reiterate what y'all both said. Stay home, wash your hands, and if there's any way we're going to get out of this, it's going to be together and with science. So, good job, guys. Give yourselves a round of applause. Oh, go ahead. Go ahead.
Oh, one last thing. When you wash I have the phone on the couch here. When you wash your hands, you have to go in between your fingers. You have to hook them up like this and get your fingertips. You have to get your thumbs.
Oh, nice. All right. Round of applause.
Yeah.